In this video, we're going to be talking about domains of functions. So we're going to start off by looking at some graphs that have a domain of all real numbers or negative infinity to infinity. You see, if you plug in any x value, it'll give you some y value that's on the graph. But not all functions can have a domain of all real numbers. Some of them are going to be restricted. Specifically, piecewise and trig functions, which we're not going to get into today, even radicals, so that would be square roots, fourth roots, and rational functions. So that's when we could have x's in denominators. Starting off with square roots or even radicals, if we see the square root of x plus 4, notice that there's no points before negative 4. So the domain is going to be negative 4 to infinity, or x is greater than or equal to negative 4. We could have found that without graphing by plugging in what's under the radical. It has to be greater than or equal to 0 because we can't square root negative numbers. And then we can solve for x from there, and we get x is greater than or equal to negative 4. So if you had a harder square root like 3x plus 2 and we didn't want to graph it, same thing, just set what's underneath greater than or equal to 0, and then you can solve for x from there. Another graph, we have an x in a denominator, so that is also an opportunity where we could probably have restrictions. There's an asymptote, so it skips over the graph, it skips over the point negative 4, which gives us this domain, or you can write it this way as well, all real numbers except negative 4. And we could have found that by not graphing, because denominators, they are allowed to be negative and they are allowed to be positive, but they can't equal 0. So if we set x plus 4, that's not allowed to equal 0, and then solve for x, so x can be anything except negative 4. And you can do this with any denominator, so if it's 1 over 3x plus 2, you don't have to graph it. You can set the denominator can't equal 0, and then you can assume that it can equal anything else. But when in doubt, graph on the calculator, and that will oftentimes give you your restrictions.